Have you ever really truly looked up?
Mm.
I mean, beyond just a quick glance, what's directly over your head right now?
It's funny, you don't really think about it much, do you?
Exactly. Most of us rarely give the ceiling a second thought. It's, often the most overlooked surface in a room.
Just sort of blends into the background.
Yeah, just blending in, yet it's silently performing this incredible array of tasks, shaping our experience of a space in ways we don't even consciously realize.
Hmm.
Welcome to the deep dive, where we take a stack of your sources and really extract the most important nuggets of knowledge.
Giving you that shortcut to being truly well-informed.
Precisely. Today, we're embarking on a deep dive into something that quite literally hangs over our heads: ceiling construction.
Sounds fascinating, actually.
Yeah.
More complex than you'd initially think.
Oh, definitely. Our source material for today is a really interesting look at the technical and design aspects of, overhead limits and ceiling planes.
Drawn from some excellent texts on interior detailing and building construction, I believe.
That's right. So our mission today is to uncover just how much thought, design, and frankly, engineering goes into what seems like just a lid over our heads.
You're about to see the ceiling in a whole new light.
I hope so.
Yeah.
Okay, let's unpack this then. You might think a ceiling is just there to keep the rain out or, hold up the next floor.
The basic functions.
Right, the basics. But it's so much more. Our sources really highlight its incredible versatility. It goes way beyond simple aesthetics or just basic structural necessity.
Foundational, really.
Exactly, a foundational element of any interior.
And what's fascinating here is precisely that point you made earlier. The ceiling's sheer, often unacknowledged yet pervasive presence.
Right.
Our source immediately emphasizes that the ceiling plane is one of the most significant elements of interior design.
That probably surprises a lot of people.
I think it does, given how often it's treated as, maybe an afterthought in a room. But consider this. It occupies a large proportion of the total visible surface area of any interior space.
Wow, okay. When you put it like that.
Think about it. Wherever you are indoors, your ceiling is almost always in your direct or peripheral line of sight. It's this huge, expansive canvas that defines the upper boundary of your world within that building.
Yeah.
And beyond just its visual dominance, it simply must perform a wide variety of functions. It's really not just a blank canvas. It's a highly active, functional surface that profoundly influences our experience.
So it's not merely about aesthetics then. It's a true workhorse.
Absolutely. Quietly doing a heavy lift for the entire space.
And shaping our perception of it, too. So what are some of these critical functions that, elevate it beyond just a decorative surface?
Precisely. It's an interior designer's really powerful tool, not just to make a space look good, but to fundamentally define and give a character to a space, as well as fulfill all the functional requirements. And this can range from the most basic, like simply covering the building's raw structure, and unsightly mechanical services.
Like pipes and wires.
Exactly. Think of all the pipes, wires, ducts. All that stuff that's integral to a building's operation, but you rarely want to see it.
Right. Keep it hidden.
That's the essential concealment role. But beyond that, a ceiling can play much more nuanced roles.
Like what?
For instance, it can actively contribute to giving scale to a space.
How does that work?
Well, a vast, cavernous room can be made to feel more intimate, more human-scaled, by a strategically lowered ceiling section, maybe over a seating area, for example.
Ah, I see. Makes it feel cozier.
Exactly. And conversely, a relatively small room can be made to feel grander, more expansive through clever manipulation of ceiling height and design, drawing the eye upwards.
Okay, that makes sense.
It can even be instrumental in creating a variety of experiences within an environment.
Variety of experiences.
Yeah, imagine a retail space where, say, a section of the ceiling is lowered, or uses different materials to draw you into a specific product display.
Subtly guiding you.
Precisely. Subtly guiding your movement or even altering your mood. It's a critical dynamic component, definitely not static.
That makes perfect sense. It's about manipulating perception and enhancing functionality. So given its fundamental role, how do ceilings even come into being, structurally speaking? Are they just sort of added on?
Or are they an intrinsic part of the building's skeleton?
Yeah.
Fundamentally, ceilings are formed by the undersides of floor and roof structures.
Okay, so the bottom of the floor above.
Essentially, yes. That's the foundational layer. The raw underbelly of the building's horizontal divisions could be a concrete slab, wooden joists, steel beams.
Got it.
From there, the actual ceiling material, the finish, can be handled in a few distinct ways. each with its own implications for design, function, even cost.
Right.
It can be attached directly to the structural frame, creating a continuous integrated surface. Often mirrors the exact form of the structure above.
Like drywall on joists in a house.
Exactly like that. Or,
Right.
quite differently, it can be suspended from it.
Suspended. Okay. That sounds more complex.
It is. And it opens up a whole new realm of possibilities, especially in commercial buildings or larger spaces where you need that hidden void.
And sometimes you don't even need to add a separate material, right? I think you mentioned.
That's the third way. In some cases, the structure itself becomes the ceiling.
Just leave it exposed.
Exactly. Our sources note that in some cases, the overhead structure can be left exposed and serves as the ceiling itself.
That's a very deliberate choice, isn't it?
Oh, absolutely. It's a common aesthetic choice now in modern, industrial chic, or even minimalist designs.
Right. You see that a lot.
Here, the raw concrete slab, the network of steel beams, the timber joists, they're celebrated rather than hidden. It embraces the utilitarian beauty of the building's bones. But this raises a really important question for any designer or builder. How does each of these approaches, exposed, directly attached, or suspended, dictate the possibilities for the space below?
Because the choice isn't just cosmetic.
Not at all. It profoundly sets the stage for everything else. It influences acoustics, lighting, how you integrate services, even thermal performance. It's a fundamental decision.
Okay, this is where it gets really interesting for me. Our source lists so many functions for ceilings, way beyond just covering things up.
It really is like a central nervous system for the room, isn't it?
Yeah, yes. Silently managing all these critical operations and hidden processes. So what are the key categories of these functions our sources highlight?
Indeed. It's far more complex than just a lid. Let's unpack the full spectrum of ceiling functions our material outlines, because it really demonstrates how vital this element is.
Okay.
First and foremost, and maybe most fundamentally, it's about covering structure, electrical, and mechanical services.
The hiding function again.
Yes, the essential concealment. This is the foundational, often unseen role. Imagine walking into a high-rise office building if all the pipes, the wires, the massive HVAC ducts were fully exposed overhead.
Chaos. It would be visual chaos.
Yeah. Exactly. Distracting, impractical, potentially unsafe, hard to clean. The ceiling provides that crucial concealment. It allows the rest of the space to be clean, organized, focused.
Creates that separation between the guts and the people.
Precisely. But beyond concealment, ceilings also make a significant contribution to the overall design concept of the interior design.
Right, the aesthetic part.
And they're vital for defining space.
Defining space. How so? Without walls.
Yeah, subtly. A ceiling can delineate different functional zones in a big open-plan office or a store without physical walls.
Oh, okay.
Like a lower ceiling over a lounge area creates intimacy. A higher ceiling over a main walkway conveys openness.
It guides your feeling about the area.
Exactly. You can visually shrink a large room or elevate a low one just by manipulating its height or shape.
Okay. What else?
They're crucial for controlling sound.
Acoustics. That's huge.
Absolutely huge. Think about the echo in a gym versus the quiet needed in a recording studio.
Or a concert hall.
Or a concert hall, a busy restaurant, a quiet office. The right ceiling material and design can absorb echoes, block noise from above, diffuse sound.
Make conversations clearer.
Yes, create a pleasant auditory environment. Similarly, they are key in providing light reflectance.
Reflecting light. How important is that?
Very. It directly impacts how bright or dim a room feels and how efficient the lighting system is.
So a light ceiling makes the room brighter?
Generally, yes. A light-colored, highly reflective ceiling bounces light around, makes the space feel larger, brighter, potentially saves energy by needing less artificial light.
And a dark ceiling absorbs light.
Right. Makes the room feel moodier, more intimate, but might require more lighting.
Interesting. So it's managing sound and light. What else?
This is where it becomes that integration hub, the real utility player.
Okay.
It's designed for holding luminaires.
Luminaires. Fancy word for lights.
Yes. Basically lights. Essential for any space. But it's not just hanging a bulb. Modern ceilings integrate recessed downlights, linear fixtures, accent lights, emergency lighting. All precisely placed.
Planned out.
Very much so. It's also critical for holding sprinkler heads.
Fire safety. Super important.
Absolutely vital. Distributing water in an emergency, often a code requirement.
Right.
Furthermore, it holds supply air registers and return air grills.
HVAC stuff. Heating and cooling.
Integral components. Bringing in fresh conditioned air, taking out stale air. maintaining comfort and air quality.
It's incredible how much is woven into it.
Yeah.
The integration hub idea is spot on. It really does sound like this carefully choreographed dance of essential services.
Absolutely. And the technological support integrated into ceilings is just growing constantly. It's becoming a smart surface.
Smart surface.
Yeah, they're engineered for holding speakers, smoke detectors, and other electrical equipment. Integrating seamlessly with smart building tech, security systems, communication networks, maybe even motion sensors or environmental monitors now.
Wow, all hidden away.
Allows for a clean, unobtrusive installation, prevents ugly surface-mounted boxes, keeps the aesthetic clean.
Makes sense.
And finally, they provide supporting ceiling-suspended elements, such as signs or curtains.
Oh, right. Like signs in an airport?
Exactly.
What?
For wayfinding in big public buildings. Or maybe curtains to create temporary room divisions for events.
Or hanging art?
Or decorative elements, art installations, yeah. Adds another layer of function and design flexibility. It's a dynamic platform, not just a static boundary.
So what this all means is the ceiling is truly an active, living part of the building.
Not just a passive surface.
Definitely not. It's a carefully engineered system integrating with basically every other critical system, fire safety, climate, IT.
Everything.
It's truly remarkable how much goes on, often unseen, right above our heads, making a space functional, safe, and looking good. It's a silent powerhouse.
Well put.
Now, beyond the main, big ceiling plane, our sources highlight some specialized elements, things like soffits, canopies, and clouds.
Ah, yes, the more localized treatments.
They sound like specific architectural components, right? Designed for maybe more targeted functions or specific aesthetic effects within a larger space.
That's exactly what they are. They represent more targeted applications of ceiling design, often used to achieve specific goals that complement or modify the main ceiling plane.
Gives more nuanced control.
Precisely. Let's start with soffits, sometimes called soffit ducts, but that's just one use.
Okay, soffits, what are they?
These are distinct architectural features that are built down from ceilings.
So a dropped section.
Yeah, picture a portion of the ceiling that drops lower than the main plane, usually along the edge of a room or maybe above cabinets.
Right, I've seen those. What's their main purpose?
Highly practical, usually. It's to hide ductwork and other mechanical equipment at the perimeter of a room.
Concealing again.
Instead of having exposed HVAC ducts or pipes running along the wall, a soffit creates a clean, enclosed chase for them. Keeps the look tidy.
Where do you usually see them?
Often in commercial hallways where services run overhead, or in residential kitchens where they fill spaces above wall cabinets or shelving.
Oh, right. Above kitchen cupboards. Gets rid of that awkward gap.
Exactly. Provides a finished, built-in look, eliminates that awkward dust-collecting gap, and integrates the cabinets seamlessly.
So, connecting that to the bigger picture.
Soffits are really a clever architectural device. They conceal necessary but unsightly surfaces, allow for a clean visual line where walls meet ceilings, or provide that refined look above built-ins. They streamline the room's appearance while hiding essential infrastructure.
Okay, got it. And what about ceiling canopies and ceiling clouds?
These sound quite artistic, don't they? Even whimsical with clouds.
Yeah. Are they just for looks, or do they have a job to do?
They certainly can be artistic, yes, but their functionality is often key. Our sources describe them as being made of fabric, acoustical tile, metal, translucent plastic, or other materials.
Wow, lots of options.
Huge range, which tells you there's significant design flexibility. They can fit almost any aesthetic, high-tech office, cozy restaurant, whatever.
And their function?
Their core function is to allow ceilings to be dropped over small areas, even below other ceiling finish materials.
Small, localized area.
Yeah. So imagine a big, open-plan office with a high ceiling. You might install a cloud or a series of canopies right above a specific workstation area, or a conference table, or the reception desk.
Defines that zone.
Exactly. And they are typically suspended from pennants or wires.
Ah, so they look like they're floating.
Gives them that floating sculptural quality.
Yeah.
Differentiates them from a continuous ceiling. Allows for creative shapes you couldn't get otherwise.
Cool. Any other benefits?
Crucially, and this is a key functional benefit often missed, they usually allow access to equipment on the ceiling above. Because they're localized drops, not a full ceiling, the space around them is still open. Provides pathways for maintenance, getting into the plenum, maybe letting light filter down from skylights.
That's clever. Design plus practical access.
Ingenious, really. Combines a distinct aesthetic element with practical access. And very often significant acoustic benefits too, especially in big open spaces. They absorb sound right where people are talking.
Okay, so these are like targeted ceiling treatments serving specific zones within a larger space,
Mm,
maybe for acoustics in a noisy area or highlighting a reception desk with cool lighting.
precisely. They give designers an extra layer of control for tailoring specific microenvironments. Enhancing function within a bigger room adds a really nuanced layer to that overhead realm.
Got it. So moving on, our deep dive now really gets into the different philosophies behind ceiling design. The source outlines the three main ceiling concepts.
Yes, the fundamental approaches.
These seem to fundamentally alter how a space feels, how it functions, even how its services are managed. These aren't just material choices, are they?
No, not at all. These concepts define the basic relationship between the visible ceiling and the building's structure and services underneath or above.
And that influences everything.
Pretty much everything. Aesthetics, functionality, sound quality, maintenance access.
Right.
It all starts here.
Okay, what's the first concept?
The first one is exposed ceilings.
Exposed? That seems pretty straightforward, right? Just leave it all visible.
In essence, yes.
But what are the key implications of choosing that?
Exactly.
Oh.
An exposed ceiling concept means the overhead structure can be left exposed and serves as the ceiling. As you said, leave it all hanging out.
Where do you typically see this?
It's a deliberate design choice, often seen in industrial-style lofts, contemporary offices, art galleries, trendy shops, or restaurants. Right, the industrial look.
It's a philosophy that celebrates the raw building elements, the concrete, the steel beams, the timber joists, the visible ductwork, conduits, sprinkler pipes.
Embraces that utilitarian aesthetic.
Often paired with minimalist or modern design. And it can create a real sense of spaciousness because you get the full structural height.
Makes the room feel bigger.
Definitely. But it comes with its own set of challenges, right?
Oh, absolutely. Acoustically, all those hard, exposed surfaces can lead to lots of echo and noise.
So you need to add things to absorb sound.
Often, yes. Additional acoustic panels or baffles might be needed, and visually it means all those mechanical and electrical systems become part of the look.
So they have to be neat.
Meticulously coordinated and exceptionally neat installation is required. Every pipe, every wire has to look good because it's on display.
Maintenance might be easier, though.
Potentially, since everything's visible. But dust accumulation on all those exposed surfaces can also be a pain to deal with.
Trade-offs.
Always. This concept really speaks to transparency and authenticity in design, letting the building's working parts tell their story.
Okay, concept number 2.
The second concept is direct attachment ceilings.
Direct attach.
With direct attachment, the ceiling material is attached directly to the structural frame.
Like we said before, drywall on joists.
Exactly. This is arguably the most common approach in many buildings, especially houses. It creates a more unified, often lower ceiling plane that closely follows the structure above.
A clean, continuous surface.
Right. Very common where ceiling height is limited or you just want that clean look. It offers a solid monolithic feel, a smooth canvas for paint or plaster.
Uncluttered.
Very. Simplifies construction too. Eliminates the need for a suspension system. Minimizes ceiling thickness.
But what's the downside?
The big one is access. It severely limits access to overhead services once it's finished.
So if there's a leak?
You're cutting holes. If you have plumbing or electrical issues, you probably need to cut the ceiling open, fix it, then patch, sand, and repaint.
Disruptive and costly?
Can be, yeah. It really prioritizes that seamless appearance over easy access to the building's infrastructure.
Okay. And the third concept, this feels like the big one, especially for commercial spaces, suspended ceilings.
The SCS, Suspended Ceiling System.
They feel the most complex. There's clearly a lot more going on there than just drywall. So what drives the choice for this approach?
Well, it raises that important question. Why suspend a ceiling at all, given the extra complexity?
Right.
In a room with a high structural ceiling, all or part of the ceiling can be dropped for several really compelling reasons. It's a balance of aesthetic and practical needs.
Like what?
One reason is to lower the scale of the space, make it feel more intimate or human-scaled.
Especially in huge rooms.
Exactly. Large, cavernous rooms can feel overwhelming. A lower ceiling can create comfort, enclosure. Another reason is to differentiate an area from the space around it.
Creating zones without walls again.
Yeah, defining distinct zones in an open plan layout. Maybe a focused work area or a collaborative lounge zone, subtly defined by that lower ceiling plane. Provides visual cues.
Okay, so scale and zoning. But there's a bigger reason, right?
Yeah.
Especially commercially.
Oh, by far the most significant reason, particularly in commercial spaces, a suspended ceiling system, SCS, is often used to provide a concealed space.
A void.
Exactly, a concealed space for mechanical ductwork, electrical conduit, plumbing lines, data cabling, fire suppression systems, you name it.
The plenum.
That's the one. This hidden void is often called the plenum, and creating it is paramount for managing a building's incredibly complex and ever-evolving infrastructure without it being visible.
Because modern buildings just have so much stuff.
An enormous amount. Think of a modern office. Hundreds of computers, AC vents, complex lighting, fire safety systems. A suspended ceiling provides the space to run all these services efficiently, neatly.
But still lets you get to them.
Crucially, yes, while still allowing relatively easy access for maintenance, upgrades, troubleshooting. Without it, the sheer volume of services would make a traditional exposed or direct attached ceiling just impractical and visually overwhelming.
So it's about sophisticated design control and pure practicality, hiding the guts, managing perception, and providing flexibility.
It's really a genius solution for the demands of modern commercial architecture. Incredible flexibility.
Since these suspended ceilings are so crucial, especially commercially, let's maybe unpack this a bit more. The source really details how they work, moving beyond just the concept to the actual integrated systems.
Yes, what makes them so indispensable in those settings.
Yeah.
This is where the ingenuity of modern building design really shines. It shows how what looks like a simple surface is actually a highly sophisticated multifunctional system, engineered to maximize efficiency and safety in busy environments.
How so?
Well, one key advantage is their integrated functionality. Our sources note that light fixtures, air conditioning registers, sprinkler heads, and sound systems can be integrated with the grid of modular ceiling tiles or panels.
So everything fits together neatly.
Precisely. The ceiling isn't just a surface, it's a precisely planned network for delivering essential services below. Every recessed light, every air vent, speaker, camera, sprinkler head is designed to fit within this modular grid.
Creates a cohesive look.
Yes, and highly functional without visual clutter. Allows designers precise control over light, air, sound for optimal comfort and productivity. It's a masterclass in organized utility.
Okay. What else makes them so key?
Another absolutely critical aspect, often overlooked, is fire protection.
Ah, right. You mentioned that earlier.
Our source specifically points out that the ceiling membrane can be fire-rated and provide fire protection for the supporting overhead structure.
How does that work?
It's a fundamental safety feature. In a fire-rated suspended ceiling system acts as a crucial barrier. It can be engineered to contain flames and smoke for a set time, maybe an hour or two.
Buys time for people to get out.
Exactly.
Yeah.
Buys valuable time for evacuation and for emergency services. And importantly, it protects the structural integrity of the floor or roof above it from the fire.
Preventing collapse.
Yes, preventing premature collapse and stopping the fire spreading further. It's a vital part of the building's life safety strategy, often mandated by codes.
Wow, okay, that's huge. So let's get practical. What are the actual bits and pieces, the typical SCS components?
Understanding these parts helps grasp the whole system and appreciate its clever modularity. The basic setup consists of modular acoustical tiles supported by a metal grid suspended from the overhead floor or roof structure.
Modularity is key, you said.
Absolutely key. For flexibility and, crucially, access. Need to fix a pipe, change a wire, get to HVAC equipment, add new tech. You just remove one or more tiles.
Pop them out.
Simple as that, usually. This ease of access significantly cuts maintenance time and costs compared to ripping open and patching drywall.
Makes sense. What about the grid itself? Does it always look the same?
No, there's flexibility there too.
Yeah.
The metal grid may be exposed using lay-in tiles. That's common in offices where you see the grid lines.
It's a standard look.
Often more cost-effective, easiest access. Or it can be concealed using tiles with tongue-and-groove or curved edges.
Concealed grid, how does that work?
The edges of the tiles fit together or slot into the grid in a way that hides the metal framework. Creates a smoother, more monolithic look where the grid lines are nearly invisible.
More refined.
Exactly, a bit less industrial.
And what holds it all up?
The source highlights the fundamental parts, the skeleton, the hanger wire. Usually galvanized steel wire drops down from the main structure above, provides the vertical suspension.
Okay.
Then the runner, that's the main load-bearing support beam of the grid, runs typically in one direction, defines the main module.
Got it.
And finally, the cross T spans perpendicularly between the runners to form the smaller grid for the individual tiles.
Hanger wire, runner, cross T.
Those three working together. precisely engineered to give the suspended ceiling its stability, its load-bearing capacity for tiles and fixtures, and its flexibility.
It's clear this is a complete integrated system, designed for critical service delivery and safety. Far more complex than just a few tiles hanging from wires.
It really transforms the overhead space into a dynamic utility zone.
Like a meticulously organized motherboard for the building.
That's a great analogy.
We keep hearing about acoustical tiles in these suspended ceilings. What precisely are they made of? And what makes them acoustical?
Good question. They have a very specialized purpose beyond just being a clean surface.
Right.
They absolutely do. Acoustical tiles are a key component, specifically designed for sound control and practical access. They are modular units of mineral or glass fiber.
Mineral or glass fiber? Why those?
Because of their unique, porous, fibrous nature. Unlike hard surfaces that reflect sound, these fibers trap sound waves within their structure. They absorb them instead of letting them bounce around the room.
Reducing echo.
Exactly. Reducing echoes and overall noise levels, often quantified by an NRC rating noise reduction coefficient, which tells you how effective it is at absorbing sound.
Where is that most important?
Crucial in places like open-plan offices, schools, busy restaurants. Anywhere, uncontrolled noise impacts productivity, comfort, or just being able to hear clearly.
Makes sense. Do they always look like plain white fiber?
No, sometimes these tiles are finished with other materials, like wood, vinyl, aluminum, or ceramic, depending on the aesthetic and functional needs.
Examples?
Well, a vinyl finish might be used for easy cleaning and moisture resistance in a hospital or kitchen. Wood might be chosen for a warmer look in a lounge or upscale shop.
Okay.
But critically, and this is central to suspended ceilings, these tiles are usually removable for access to the ceiling space.
Easy access again?
That removability is what makes them so incredibly practical for maintenance, upgrades, troubleshooting all the hidden services. Lift a tile, immediate access, no destruction.
It's fascinating how these seemingly simple tiles are engineered for both sophisticated sound absorption and essential practical access.
Contributing significantly to comfort, function, and long-term maintainability.
A prime example of form-meeting function, quietly enhancing our environments.
Exactly.
Okay, our source then introduces a term many might not know, but it sounds vital for understanding these systems. The plenum.
The plenum. Absolutely essential.
What exactly is this mysterious unseen space? And why is it so critical?
You're right. It often goes completely unnoticed by people in the building, yet it's working tirelessly behind the scenes. It's defined simply as the open area between the floor above and the top ceiling below.
So the gap.
Essentially, yes. If you're in a room with a suspended ceiling, the plenum is that hidden void, that airspace, right above the tiles and below the structure above it. A large, unoccupied cavity.
And why is this open space so critical? What goes on in there?
Well, it accommodates the mechanical and electrical equipment that is used as part of the air distribution system, but it's really much more than just that.
Okay.
In essence, it's the hidden highway. For your HVAC ducts carrying conditioned air, electrical conduits powering everything, fire suppression pipes, communication cables for internet and phones, sometimes even security wiring.
All crammed in there.
All neatly organized, ideally. In many commercial buildings, the plenum itself is even used as a return air pathway for the HVAC system.
How does that work?
Drawing stale air back into the ventilation system through the plenum space without needing extra return ducts. Saves space and cost.
Wow.
So it's the concealed network that lets a modern building function. It's the lungs, the circulatory system, the nervous system, all hidden by the suspended ceiling.
Without that dedicated space.
Integrating the vast array of services in contemporary buildings would be incredibly difficult, inefficient, and visually just a mess.
Here's where it gets really interesting for me. So the very air you breathe in a building, the power to your lights, the data to your devices, the fire safety systems, all that essential infrastructure often lives in this hidden void.
Tucked away in the plenum.
It's the silent workhorse, making sure everything runs smoothly without us ever seeing that intricate web.
It's truly an engineering marvel we often take completely for granted.
Speaks volumes about the hidden complexity of modern architecture.
Absolutely.
Okay, so our source then broadens our perspective again, moving beyond those three main concepts to discuss combination ceilings and then closed versus open concepts.
Right, looking at the broader aesthetic and functional possibilities.
It seems like the design potential is truly vast, offers incredible flexibility.
These broader categories offer a glimpse into that diversity. How designers meet specific project needs or create unique environments allows for a highly nuanced approach.
So first, the source mentions combination as a concept. What does that mean?
This is incredibly important, actually. It implies that designers often blend the exposed, direct attachment, and suspended concepts within a single space.
Mix and match.
Exactly. To achieve varied effects or meet complex functional demands. For example, a big open office might have a suspended ceiling over the main workspace for acoustics and services, but maybe an exposed concrete ceiling in a breakout area for that raw industrial look.
Okay.
And maybe a directly attached gypsum board ceiling defining a quieter, private office for a more traditional feel.
So layering the concepts.
Strategic layering allows for immense creativity and practicality, tailoring different zones to their specific function and desired atmosphere, leveraging the strengths of each concept.
A nuanced approach. Got it. Then we move to the distinction between closed and open ceiling concepts. Let's start with closed ceiling concepts.
Right. Closed ceilings are those that create a continuous, often uninterrupted surface,
Hiding everything above.
completely concealing the structure and surfaces, presenting a finished, cohesive plane. Emphasizes refinement, minimizes visual distractions.
And there are variations.
Our source highlights several variations within this category, each offering distinct visual and spatial qualities.
Okay.
First, modulated planar. This means a largely flat surface, but with subtle changes or breaks in elevation, or maybe changes in material within that plane.
Not just flat and boring.
Right. Creates visual interest, can subtly define zones without dramatic drops, adds depth.
Next.
Angled. Ceilings that slope or feature distinct angles, moving away from the flat horizontal.
That's drama.
Can add dynamic movement, architectural drama. Directs the eye, creates motion, maybe mimics the roofline. Think vaulted ceilings. Can feel expansive.
Okay. Then there's
Curved. Ceilings that arc, undulate, or dome create soft, organic forms.
Oh, that's elegant.
Can evoke fluidity, warmth, luxury. Often seen in grand public spaces, lobbies. And beyond aesthetics, curved surfaces can help with sound diffusion too, break up echoes.
Ah, functional curves.
Sometimes, yes. And finally, change of material planar with drops.
A bit of a mouthful.
Yes. It involves combining different materials within a flat plane, maybe gypsum board next to wood panels, or a metal insert. And it can include localized drops like integrated soffits or small canopies for visual effect or to house lights.
So connecting this all?
These variations in closed ceilings dramatically alter light reflection, sound diffusion, how we perceive the volume and boundaries.
They can feel expansive, intimate, playful.
Depending on the form and material. Incredible versatility.
Okay. Now, in stark contrast to those concealing surfaces, what about open ceiling concepts? Opposite end of the spectrum, right?
Absolutely. While the source doesn't detail specific types within this category, the implication is clear. A deliberate design choice to fully expose the structural and mechanical elements above.
Like the exposed concept, but maybe broader.
Exactly. It aligns with the exposed concept we discussed, but presented here as a broader aesthetic and philosophical category. It's a statement about transparency, authenticity, often that industrial or raw aesthetic.
Where do you see this most?
Contemporary lofts, renovated industrial buildings, creative offices, bustling shops, and restaurants.
How's the look?
The exposed ducts, pipes, conduits, beams become part of the interior's visual language. Celebrates the raw function.
Can make a space feel bigger.
Definitely creates a powerful sense of height and volume, more airy, but critically.
It can't be messy.
Exactly. Open ceiling doesn't mean messy ceiling. Requires meticulous planning, exceptionally neat installation of all surfaces because they're on display.
And acoustics.
Can be challenging. Those hard surfaces reflect sound. Often needs sound-absorbing baffles or panels hanging within the exposed space to manage noise.
So it requires really thoughtful integration.
Of building systems and aesthetic intent, absolutely.
So what this all means is that ceiling design isn't just about hiding things. Sometimes it's actively celebrating the raw structure as part of the design.
Shows how flexible and impactful ceiling design is. A wide spectrum, from complete concealment to full exposure. All with specific, intentional outcomes shaping our experience.
Okay, finally, our source moves from the what and why to the how, the actual methods of construction.
Where the rubber meets the road.
Bringing those concepts to life, what are the main methods we should understand?
These are the practical techniques builders use. Each method has its own benefits. Typical uses, distinct look, require specific materials and skills.
First up.
Number 1, gypsum board, fiber cement board construction on light metal frames.
Sounds common. Drywall on metal studs.
Essentially, yes. One of the most common and versatile methods globally. Gypsum board, drywall, or fiber cement board panels attached to a light gauge steel stud or furring channel framework.
Hung from the structure.
And usually suspended from or directly attached to the structure above. Panels are screwed on, seams taped, and finished with joint compound.
Creates that smooth surface.
Smooth, continuous, monolithic, ideal for paint, plaster, other finishes. Very clean, minimalist, timeless look. Allows lots of design flexibility, different heights, shapes, coffers, coves.
What are the practical implications?
A generally cost-effective, relatively quick to install, excellent fire resistance, especially with fire-rated board.
The downside?
Limited access to services once it's up without cutting into it.
Okay, method 2.
Ceiling tile on T-runners. Acoustic board panels.
Ah, the standard suspended ceiling we keep talking about. The office ceiling.
Precisely that. Refers directly to the common modular acoustic board panels that lay in or integrate into that T-runner grid system, visible or concealed.
Why is it so popular commercially?
Highly favored in commercial, institutional settings, schools, hospitals, offices, because of its exceptional ease of installation, unmatched access to the plenum.
Pop the tile.
Right, and superior sound control properties. Those tiles absorb sound, reduce noise, improve speech clarity, vital for productivity and comfort.
And easy to change things later.
Exactly. Modular nature means rapid assembly, disassembly. Adding new fixtures, repairing pipes is straightforward. Minimal disruption.
Makes sense. What's next?
Number 3, plank ceiling.
Plank ceiling, wood.
Typically involves longer, narrower pieces of material, usually wood, installed side by side. Solid wood, engineered wood, maybe even wood-look composites.
How are they attached?
Usually directly to furring strips or joists, often with concealed fasteners for a clean look.
And the source mentioned something about framing.
Yes, it notes. Kindly observe the spacing of the framing. This highlights the critical importance of precise structural support and consistent alignment. For the look and stability, each plank needs adequate support at regular intervals to prevent sagging or warping over time.
What's the final aesthetic?
Linear, often warm and natural. Adds texture, directionality. Can be traditional, rustic, or even sleek modern depending on the wood and finish.
Sides.
Solid wood often has limited acoustic absorption unless you add backing, and can be more susceptible to humidity changes.
Okay. And the last method?
Number 4, wooden slat ceiling with acoustics.
This one sounds really nice. Natural elements plus function, especially the acoustics part.
Absolutely. Offers both visual appeal and a practical solution.
How does it work?
It involves installing spaced wooden slats, creating a visually permeable ceiling plane. Unlike solid planks, there are intentional gaps between the slats.
And the acoustics.
The with acoustics part is key. Often have acoustic material mineral wool, fiberglass, acoustic fabric placed behind the slats or in the plenum above.
So sound goes through the gaps.
Exactly. The gaps let sound waves pass through to the absorbent material, which traps the sound, prevents echo, creates a more comfortable acoustic environment, important in open spaces, lobbies, auditoriums.
What's the look?
Contemporary, sophisticated, often warm. Allows partial views of the structure or surfaces above. Can integrate lighting shining through the gaps. Still provides significant acoustic performance.
Lots of design options.
Huge. Choice of wood, slat size, spacing dramatically alters the look. Minimalist grid to rich texture.
Any drawbacks?
Can sometimes be a bit harder to keep dust-free than a smooth ceiling.
It's incredible, though, how design and engineering meet to create both beauty and high-performance function, even in something seemingly simple as a ceiling.
Transforms it into a highly sophisticated and versatile architectural element.
Well, you have just had a deep dive into the incredible, often unseen world of ceiling construction.
Quite a journey overhead.
From being just a simple structural cover to this complex system for light, sound, air distribution, fire safety, we've really unpacked its vast significance.
In interior design and building function.
We've explored how it's meticulously engineered to cover services, define spaces, control environmental factors, support integrated tech. It's truly an unsung hero of architecture.
Constantly working above our heads.
Quietly defining and serving the spaces we inhabit every day.
It's clear that a ceiling is never just a ceiling. It's a deliberate design choice, a feat of engineering, and a critical component of any functional, comfortable, and aesthetically pleasing space. Its role goes way beyond just the top boundary. It actively participates in the building's performance and our experience.
So next time you walk into a room, take a moment to look up. Really observe what's happening overhead.
See it with new eyes.
What will the ceiling tell you? About its purpose, its design intent, Maybe even the hidden life buzzing in the plenum above.
How does its chosen concept, exposed, direct, suspended, or some clever combination, influence how you perceive the space?
Its scale, its sound, maybe even your mood. The overhead realm is now open for your own deep exploration.
You'll never look at a ceiling the same way again.
I certainly won't.